Hello student, how are you? I hope you all are happy, healthy and fine at home. What were what were we discussing yesterday? Do you remember? I think we were discussing about the R and S epichlorohydrin, and we have seen how that RS epichlorohydrin synthesized in the laboratory. First of all, we have seen its retrosynthetic strategy, and after that we synthesize that R and S epichlorohydrin by using the proper reaction condition and the suitable reagent. Let us quickly revise what are the reagent we use while synthesis of RS epichlorohydrin. Number one is a sodium hydroxide in presence of methanol. Second one, acetone in presence of acid. Lead acetate in presence of the benzene, then sodium borohydride in presence of ether, tosyl chloride in presence of pyridine, aqueous HCl, then triphenyl phosphine in presence of CCl4, ethylene glycol sodium, then sodium methoxide in presence of methanol, MsCl in presence of pyridine and concentrated HCl. These are the certain near about 10 reagents we have used for the synthesis of that. Now what we are going to learn today, let us see here. We are talking about this, the Chiron approach, and in that according to our syllabus, so point number C, utilization of basic concept in the synthesis of, there are 6 target molecule. So far we have synthesized with their retrosynthetic and synthesis we have completed as a 2 molecule. First one is a propanediol and second one is a RS epichlorohydrin, and today will be the third one, that is a L plus alanine, and remaining 3 I think minus multistatin, minus pentinomycin, and last one 6th one is a sechemic acid. These are the things remaining. So let us begin with today's one is a L plus alanine. L plus alanine has the structure, as you know that the structure of L plus alanine, L and D, capital L and capital D represented by the relative configuration. You always remember, and these are 2 designation, nomenclature designation generally used in a carbohydrate and the alpha amino acids. So L and all the alpha amino acid except glycine, there are 20 amino acids are there, and rest of the 19 alpha amino acid naturally occurring has a L configuration, and their absolute configuration they are present in a S configuration, that you should remember over there. Now here is a plus indicate as a dextro rotation of this molecule, that is a L plus alanine. The structure of L plus alanine is this one here, COOH. I am writing this molecule on the basis of here H2N, here H, and here is a methyl group. So this is a structure of L alanine. Why L? Because that NH2 group, amino group, which is present on the left hand side, and therefore it is known as a L alanine. L alanine, this is one of the amino acid. So what is the specialty of this compound, let us see some of the introduction regarding that L-alanine, why we are synthesizing here. As we know that these are the medicinal compound, natural products these are, and that's why we are synthesizing these molecule by keeping the Chiron approach. And this L plus alanine, another classical demonstration of the use of carbohydrate for establishing absolute configuration of the natural product, is seen in the synthesis of the N-acetyl L plus alanine from the starting material. The precursor used here is a 2-amino 2-deoxy D-glucose. We will see its structure shortly. The sense of chirality at C2 is the amino acid was related to that in the amino sugar, and which has the acyclic dithioacetal derivative, and which we will see shortly. Their structure afford the possibility of reductive desulfonation. Desulfonation means removal of sulfur and oxidative cleavage. Yesterday also we have seen oxidative cleavage is occur. The suitable reagent used for oxidative cleavage is the lead tetraacetate, that is a PbOAc 4 times, and 3 asymmetric centers are destroyed in the process, but the stereochemical correlation is the pivotal issue in such a scheme. That scheme we will see shortly. And thus this type of degradation has in place fact been used in the other instances as the example in the establishment of the partial stereochemistry of amino sugar in same amino glycoside antibiotics and access to other amino acids such as L-serine, L-threonine from 2-amino 2-deoxy D-glucose has been investigated in a different content. Mention should be made of the synthesis of a chiral ethanol D from D-glucose. Let us see here L plus alanine. Just now we have seen this is the structure of L plus alanine. This L plus alanine is unstable. It is kept in acetic anhydride, and therefore, and as we know that amino acid are very reactive functional group, it react with acetic anhydride and that get protected, and we will get N-acetyl N-alanine. That is the compound we are getting here. L plus alanine is alpha amino carboxylic acid. It can be synthesized from 2-amino 2-oxy D-glucose, and this alpha amino acid is unstable or highly reactive, as a result of which it is kept in a protected form, that is in the presence of acetic anhydride to form a N-acetyl N-alanine. And therefore let us see here the retrosynthesis of this compound. Retrosynthesis, first point is a retrosynthetic analysis. That first point we are going to see here. There is a retrosynthetic analysis. What does it mean? Retrosynthetic analysis means what? The process of breaking down target molecule into convenient starting material by using disconnection and FGI is known as a retrosynthetic analysis. That analysis we have seen over here, and that disconnection means what? An analytical operation which break a bond and convert a molecule into a possible starting material is known as a disconnection, and always we are return the FGI over that disconnection arrow. FGI means what? functional group interconversion means one of the functional group is converted into another functional group so that this connection becomes possible is known as a FGI, and this is the retrosynthesis. And retrosynthesis, as we know, that an imaginary but logical reverse chemical reaction which help us to reach the reactant starting from the target molecule is known as a retrosynthesis. And here by doing as a this one, this is a disconnection arrow, and we are writing FGI written over the arrow. And what do you get over here? Here look at this type of the thing is you are going to go get here OH, then there is a HO. This is FGI means function, one of the functional group we are converting into as another so that this connection becomes as a possible, and therefore we are converting this into this one. Now here OH, here OH, then next one here will be the NH2, then C double bond OH, that is a alpha amino this type of the acids over there, and that's why we are writing this one. And this can be again written as a FGI, functional group interconversion. And this functional group, look at here at two position, this amino group, this is alpha amino acid type of the sugar it is there, and now this carboxylic group we can obtain from aldehyde group, right? So that we are converting it into this one C double bond OH. Rest of the thing remains as it is NH2. Then here OH above, one OH below, and then there is a OH, and this group, that is a alpha amino sugar type of the aldehyde is there, and this again we can do with this FGI, functional group interconversion, and now this can be joined over there, and you are going to get the product like this. And this one here we can get OH over here, this NH2, then this OH, then HO, then this one HO, and this is our what we can call it as a chiral precursor. The name of this compound as a 2-deoxy, means at two position there is no hydroxy groups here, therefore 2-deoxy D-glucose. This is the structure of 2-deoxy-glucose or glucose, and this can be, if you convert this molecule into as OH, you will get the structure of the D-glucose, and D-glucose are this is a sugar unit, amino sugar unit, and from that we can prepare. This is a retrosynthetic analysis. This is for half mark means suppose is a 4 mark question, you will get as a 2 mark here. This is a retrosynthetic analysis what we did, and this is a L configuration, L alanine, because that NH2 group on the left hand side, and they look at here, they if you see here what is the configuration of this, whether it is R configuration or S configuration, as we know that naturally amino acid has a L configuration, and absolute, if you talk of in case of the absolute configuration, this will show the R configuration. Here look at one, this will be the second, this will be the third, so this is a R, fourth one present on a horizontal one, and therefore R changes into as a S, and therefore it has a S configuration, that is a alanine, and we are getting as a this type of the compound. So this is a retrosynthesis of this molecule, and now let us see, start with the now is a synthesis of this compound. Now is a synthesis. Let us see how we can synthesize this compound in the lab. Now start the synthesis. Second part is a synthesis. Second part is the synthesis. Look at here, this is our starting material. So here you can take this starting material as it is. Here OH at 2 position, NH2, OH above the plane, here OH below the plane. At this there is a hydroxy group. This is called as a 2 D-glucose. This is a starting material. Now this compound treated with first one is a acetic anhydride. As we know that the structure of acetic anhydride is this one. We generally writing as acetic anhydride CS3, C double bond O, then C double bond O, CS3. Means sometime it is written as a M.Sc.II. also called as a this acetic anhydride. So I am writing here the acetic anhydride in presence of the ethanol, ETOH, or we can use as a methanol. What it will do? It will protect the controlled reaction. There are the number of hydroxy groups are there, but it specifically NH2 group is a more reactive over the hydroxy because it is a more nucleophilic in nature than the hydroxy group. The reason behind it, the nitrogen atom is a less electronegative than the oxygen atom, and therefore the oxygen has a more capacity to hold the electron tightly, and therefore the nitrogen atom is more reactive toward this, and you are going to get the product over here. This one, this is a product you are going to get here O, then O, not O, here is a this one OH. Here what is going to happen? NH, C double bond O, this type of the acetyl group connected over there. Other thing remains as it is. Look at this retrosynthetic carefully, and then you will see other thing remains as it is HO, and here again is a this one HO, that is also as a remains. Everything is remains same, only that amino group get acetylation, get protected or get reacted. We are getting as a this type of the product. After that, what you are going to then this structure can be present at an equilibrium. Equilibrium arrow is like this, so that we can write the structure like this. So you will get this one OH, then HO over there, this remain as it is, then OH. Now here C double bond O, aldehyde group, and here NH, then C double bond O, this type of the group remains as it is. Understood this one? Now this compound here is a aldehyde group, and as we know that aldehyde group is a reactive one, it is further treated with that ethyl thiol, that is a ethyl alcohol like that, but it is the ethyl thiol. Here we are getting in presence of the H plus. 2 moles is reacted with this carbonyl group. Here 2 moles of ETSH get reacted, and what it will give? It will give you the product. Other carbon framework remains as it is. The sense of chirality here just now we have seen at a C2, and now at this carbonyl group, these two are going to react, and what you are going to get in this case, you will get the product here like this. Other thing remains as it is, so you write that thing as it is. Hydroxy group below the plane, here hydroxy group above the plane, this one acetyl group, C double bond O, this group as it is. And now here what is happening here? Here only, here SET and here S-E-T. That hydrogen atom still there. I am not showing that hydrogen atom. You imagine here this carbon atom has bearing one hydrogen atom, and that is a group over there. Understood this one? Now this will be treated with, and after that the reagent used over there. Let me clean the board over here so that you can see clearly the other things. See over here. Now the things, what is happening here? This one, this will be treated with Rane nickel, as we know that. Rane nickel means CH2 in presence of, this is a reduction reaction. What it will do are the desulfonation of that, and this get converted into as a methyl group, as we know that. This is a use of this Rane nickel. So you are going to get over here, other thing remains as it is, so you write down that one as it is, OH, then hydroxy group above the plane, this NH, and this group acetyl group still as it is, but here becomes as a CS3. This group desulfonation takes place, and as we know that thioketone using with that Rane nickel, that convert the carbonyl group into as a in a neutral media we are getting as a this CH2 group. So that type of the application you can see over here. And after that, what you have to do next one, then there is using as a oxidative cleavage with the help of lead acetate OAC4 in presence of the benzene is used as a solvent in this case. What is going to happen here? Diol is present over there. This one you remember, this bond is going to cleave over here. Remember here how, and then you know that the mechanism is going to break over there, and here you are going to get OH. I am not writing as a above one that is a glyceraldehyde, that is a starting compound, another one, but here I am writing this one CS3, and there this NH, then double bond to this one, right? This is a part we are getting over there, and now this compound further treated with aqueous Br2 here, aqueous Br2, and what is going to happen? And as we know that Br2 is a mild oxidizing reagent which oxidize this aldehyde group in a carboxylic, and so carboxylic group, and you are going to get here COOH. I am writing now here is this one NH, this acetyl group C double bond O, this hydrogen atom here, and this CS3. Now, and after that you hydrolyze it. After the hydrolysis, what do you get? After the hydrolysis, strong acid or the alkali you can use for the hydrolysis purpose. This bond get cleaved, amine type of the bond, and you are going to get your target molecule NH2, then this one H, then COOH, and this one is a CS3. So in this way we have got the target molecule, and as we know that target molecule means what? The molecule whose synthesis being planned is known as a target molecule. So this is the thing we have seen over here. Now let us look at as a mechanism here. How the mechanism is whenever it is necessary, then you can show the mechanism over here. So let us see how the mechanism we can show whenever it is possible. We can show the mechanism. So let us see here the mechanism of this mechanism. And as we know that mechanism is a language of organic chemistry, and therefore let us see the mechanism here, how the mechanism takes place. As we know that the starting compound of this we are using, what is that? This is a compound we are using as a precursor, chiral precursor. Here remember this is a NH2 and here OH, here you can write OH, another OH here, and this primary hydroxy, and this compound is known as a 2-amino at 2 position. This is 1, 2, 3, 4, 5 and 6 membered ring. So this is a sugar unit, amino sugar unit, 2-amino, 2-deoxy, because there is no oxygen atom, instead of there is a amino group, and therefore it is known as a 2-amino deoxy D-glucose, which is a starting material used for the synthesis. And now this will be treated with acetic anhydride, C double bond O, then C double bond O H. So NH2 group, they at a control reaction, so it is attacking over there, then this get eliminated and you are going to get the product over here, this one. Here other thing remains as it is, here only one H atom over there, and H you can write here, then C double bond O, this group, and other thing remains as it is OH, this hydroxy group below the plane, this one is above the plane, and this group will be this compound present at an equilibrium. So we can show this arrow both way. So this is here is a hydrogen atom, this goes over there, this is a what we can call it is a anomeric center. Anomeric center means the hydroxy group present over there at one position, that type of the carbon atom is called as anomeric center, because it is having as a potential aldehyde group present over there, that anomeric, and therefore, and as we know that it get openly easily at an equilibrium, this ring. So at an equilibrium you are going to get the product OH, other thing remains as it is OH, then here OH, and here you can write NH, C double bond O, this as it is, and then this is a aldehyde group, right? This aldehyde group further treated with thioethyl, that is HS, then ET you can write, or ET is nothing but C2H5 you can write, or CH2CS3 ethyl group you can write, and the lone pair similar to as a ethyl alcohol, it is going to react with this in presence of the H plus. First one is the H plus, this carbonyl carbon first get protected, and due to that protection of the carbonyl oxygen, the nucleophilic attack or the nucleophilic character of the carbonyl carbon increases, and therefore it is attacking over there quickly, and you are going to get the product here. This one, let us see here, OH as it is, this OH, then OH below the plane, another OH, then you can write over here this NH, this is a group over there, then here you can write OH, and here what is that, yes, ET, and that hydrogen atom still over there. Now this is a hydroxy group, it gets protonated due to the acidic medium, and what is going to happen here when it form like this, let us see over here the structure, this one OH, that here I am writing OH2 positive charge, here sulfur ET, hydrogen atom I am not showing over here, here H double bond O, this one acetyl group, another rest of the group remains as it is, hydroxy group below the plane, here hydroxy group will be above the plane. Now OH is a bad living group, but when it becomes as a OH2, that becomes as a good living group, and therefore this is going to attack form as a double bond, and this water molecule get eliminated from here H2O, and you are going to get the product over here like this. So OH, then other rest of the group remains as it is OH, then here what is happening, this NH and C double bond O, this one also remains as it is, but here becomes as a SET, this becomes as a positive charge, and another molecule of that HSET is going to attack over there, and that get neutralize that positive charge, and you will be getting here the product, this one. Let us see here, this OH as it is, then here HO, then OH hydroxy group, here another hydroxy group over here, NH, C double bond O, this group as it is, then here what is happening here, SET, and here again is a SH, ET, here is a positive charge over there, again this proton get lost, neutralizing that positive charge, and the finally what you are going to get over here, the thing you are going to get over here, I am showing here only, look at this one, OH, here is a HO, OH, here NH, and this acetyl group as it is, but here what is we are going to get, here you are going to SET and SET, and now this compound further treated with Rane nickel, as we know that Rane nickel, it is a reducing reagent, reduction reaction takes place, or which is known as a desulfonation. Desulfonation means removal of sulfur from that, and you are going to get the product like this. The product you are going to get here, this one OH, other thing remains as it is, look at here, HO, then OH, here NH, and this becomes as a CS3 group here, and this they are remains as it is. Now let us see another one. What is the next reagent we are adding? The reagent further we are adding there is a CS3. Now we are adding the reagent PbOAC4, right? Oxidative cleavage in presence of the benzene. In presence of the benzene, I think this, what is going to happen here? Pb, I am showing over here, AC, then OAC, OAC and OAC, right? This OH is going to attack over there, removal of this OH also going to attack over there, removal of this OAT, and what you are going to get here, this one OH, here HO remains as it is, now here O, then we can show this one, here is a CS3 group, NH, I am writing here as a sake of convenience O, here PB, here OAC, here OAC, right? Or here OC, and then C double bond O, this group as it is. Now how this bond is going to break? This is going to form as a double bond over there, and this is there, and this form as a double bond with that is a glyceraldehyde, is a diglyceraldehyde we are getting, and the rest of the thing here you are going to get this product means C double bond O H, that CH3, then NH and C double bond O, this one, and other remains as a glyceraldehyde, as we know that this one OH and the OH. This is other part, is a glyceraldehyde is there, and but here we are getting as a this one amino acid we required as a this one, we can separate it, and this reagent further treated with aqueous Br2, that is it is a mild oxidizing reagent which can oxidize this aldehyde group into the carboxylic group, and what you are going to get, I am writing here according to as a Fischer projection formula, and you are going to get here H2N and this CH3, and this is nothing but L plus alanine. Not this, I think. Still, we are not here. Still, what is happening here? Let me clear here. Only this carboxylic group HO. Then, or I am writing here HOH. Here H. Here N H, and then acetyl group as it is here is a CH3, right? This type of the, and further hydrolysis, and after the hydrolysis what you are going to get? After the hydrolysis, this group is going to cleave over there by using as a strong alkali or the strong acidic medium. This get deprotected amide group, and you are going to get the final product, which is COOH. Here H, this one is a H2N, and this one is a CH3, that is L plus alanine. And in this way we have, I think, completed this one. Now what are the reagents used for this synthesis? Number one is used as a acetic anhydride in presence of the methanol and the base. Second one is used as a ethyl thiol in presence of the acidic medium. And third reagent used here is a Rane nickel for the conversion of that for a desulfonation purpose here. And third one is a lead acetate in presence of the acetic acid. The reagent used here for the oxidative cleavage that 1,2-diol get converted into as aldehyde. And finally aqueous Br is used to oxidize the aldehyde group into as a carbolic group. And lastly one is a hydrolysis, and we will get our target molecule, that is our desired product we have synthesized. And this is as we know that it is one of the alpha amino acid, and we know that they are the building block for the synthesis of that protein. I think with this let us stop today here. Remaining we will see the next time. Have a nice day. Thank you.